Okay, I'll let everyone in. Hello, everyone. Welcome to another session of the CIVICA Data Science Seminar Series. My name is Hui, and I'm the manager for the Data Science Lab at the Hertie School. Today, we have a very exciting talk for you on the applications of large language model technologies for the financial sector. We have two speakers today. First is Vincent Philip Moreau. He's currently a research assistant at Columbia Business School and also a student in the mathematics departments at Columbia University. His research interests lie in monetary theory and policy, as well as financial stability. He has also previously worked for the German central bank. And our second speaker today is Maurice Pfeiffer. He's currently a postdoc researcher at the Institute for Economics and Policy at Leipzig University. He also holds a PhD in economics from Nanterre University. And his research interests focus on currency competitions, central bank communications, and scientific paradigms in monetary policy. He's also previously lectured at the University of Nanterre and also Sciences Po Paris. And our speakers will discuss their latest work on CentralBankRoBERTa, which is a state-of-the-art large language model implementations to understand central bank communications. The speaker will deliver their talk for about 40 to 45 minutes, and then we will have a 10 to 15 minutes of Q&A at the end. Please feel free to put your questions in the chat during the talk, and then we will focus on that during the Q&A sessions a little bit later. Thank you very much. And Vincent, Moritz, the floor is now yours.
Thank you. I'll share my screen. Okay. Well, thanks everybody for coming. It's a great pleasure to be able to speak here about our latest research, which is on CentralBankRoBERTa. So an application of large language models to the field of central bank communications. And just to give you a short summary of what we've been doing, the motivation for this project stems from the observation that central bank communications have become increasingly important over the last decade. And this comes on one side from the need to enhance legitimacy. Some of us may remember the Occupy Wall Street movement and the unorthodox monetary policies that followed the great financial crisis. We've seen a huge expansion of central banks' balance sheets, and also now increasing interference or implications of the central bank on bond markets of the government and also the private sector. And with this increasing importance of the central bank in the economy, there also comes an increased need for central banks to reassure citizens of the legitimacy of their mandate and of the fact that the great power they now have is used for good reasons. And it has also been increasingly important to increase monetary policy effectiveness. For a lot of the period since 2008, since the great financial crisis, we've found ourselves at the zero lower bound, at which the interest rates set by the central bank are already at zero. And because interest rates can only be controlled on the short term by the instrument the central bank traditionally has, there is a need to control long-term interest rates by managing expectations. That is to say, by convincing the private sector that future rates will also stay low to decrease the long-term structure of interest. And following this increased importance of central bank communications, there's also an increased literature analyzing central bank communications. Most often this is done with NLP methods to produce an interpretable and consistent interpretation of central bank communications. But we have found that there's two consistent problems in this literature. For one, most studies do not consider the heterogeneity of a central bank's audience. For linguists, this might be obvious. For economists, I do not believe it is obvious. It is that central bank audiences are heterogeneous. That is to say, households and firms and banks and the government and the central bank itself do not have the same interests. And simply modeling the audience of a central bank as simply the financial sector does not capture that. Secondly, most studies analyzing central bank communications do not consider context sufficiently. This is because most of them rely on older methods that can only capture, for example, n-grams, that is strings of words. And these are deprived of context, which, as we will later see, is especially important for central bank communications. And so we started this paper with the observation that current state-of-the-art algorithms, we live in the age of ChatGPT, could handle these problems that are present in the literature. That is to say, they can grasp the nuances of central bank speak, and maybe there's also the possibility of distinguishing audiences, which has not been possible before. So our method for the paper has been to first construct a novel data set of 28,500 sentences, which most of them, or a large part, is labeled manually from Fed, BIS, and ECB speeches in an effort to make the model applicable to most central banks that speak English. And with this data set, we've constructed a two-stage model based on the RoBERTa architecture. That is, one part of our model with a given input sentence is able to distinguish the audience that is addressed, that is the households, firms, financial sector, government, and the central bank itself. So our model can tell what the sentence is talking about, or arguably to. And the second stage of our model can discriminate between positive and negative sentiment. That is to say, it can determine with respect to that audience if the sentence constitutes a positive or a negative signal. And then for the baseline comparison of our model, we also fine-tune other methods, other NLP methods, both conventional machine learning, NLP methods, and deep learning methods. And we found that our model that is based on RoBERTa architecture outperforms all the other baselines. And so this model that we've trained can provide unprecedented coverage compared to the previous methods. We will later see it can generate about 200,000 data points when the traditional methods can only generate 1,500. And it's also the first model that can discriminate economic audiences, not just for central bank communication, but general, which might be interested for some of the audience who are not in central bank communications. And for those interested in using it, it is available on GitHub and on Hugging Face. We hope to be published soon. And the hope of this project is for the central bank communications community, for central bankers, but also researchers otherwhere, to have an easy to use open access tool that perhaps can advance the state of the art in the field a bit. But let's take a step back. Why is the nature of central bank communication so different? Why can n-grams or other NLP methods not capture it? Why do we think we need a large language model? Let's take one example from Jay Powell from the COVID epidemic. With vaccinations rising, schools reopening, and enhanced unemployment benefits ending, some factors that may be holding back job seekers are likely fading. Businesses and consumers widely report upward pressures on wages and prices. Now, these two yellow marked bits of the sentence already indicate what might be some problems for traditional NLP methods. For one, what a central banker says really depends on context. So enhanced unemployment benefits ending, depending on what snippet of the sentence you take, has opposite meaning. Either it's enhanced unemployment benefits or unemployment benefits ending. So is it good or bad for job seekers? And also what a central banker says really depends on audience. Again, linguists might know this already, but economists have so far neglected this to a great extent. Because, for example, upward pressure on wages might be a negative sign for businesses who now have to pay more wages, but it might also be a positive signal for households who now see their wages rise. So a simple good, bad dichotomy for NLP doesn't capture the full extent of central bank communications. Right, and this is important because, as I mentioned, central banks can control the short-term rate of interest with their policy instruments, but the key challenge, which central banks have only been rising to in the last 20 years and increasingly in the last decade, is to control the expectations of interest. And so long-term rates can only be controlled by expectations, and those can be steered by communications. Now, and this is one of the biggest challenges in central bank communications for central banks, one challenge is that what a central banker might do is to be as deterministic as possible in his communications by saying we will raise rates in, for example, a year, and therefore enhancing potency, because I will be assured that this will happen. But this carries a risk with it that he might pivot, he might lose credibility, it might not happen. And central bank trust is something that is difficult to establish and difficult to maintain. And once it is gone, it is difficult to reestablish. So Odyssean forward guidance, that is to say, tie yourself around a mast, saying this might happen, might enhance potency, but it risks credibility. And therefore, central bankers have developed a complex coded speech that is most often implicit, where they might insinuate a rate hike without tying themselves down. And therefore, central bank speech has become very complex language that, according to Flash-Kincaid scores, requires a college degree to understand, and therefore also is very difficult to interpret for NLP methods. And by nature, it is targeted. As we mentioned, central banks have heterogeneous audiences whose interests they need to manage. They have constituencies. Even though they're not elected, they have constituents they need to satisfy, for which they need to prove their legitimacy. And so what a central banker says to a certain agent might not be said to another agent because they have opposing interests. One example from just this week or this month is Meloni, the Italian prime minister, announcing a windfall tax on Italian banks following the ECB's rate hike. And what happened, the ECB has put out a statement saying, and prefacing it, oh, we're not supposed to be political, but for reasons of financial stability, we would appreciate if Italy didn't do this. And like this very fact, the statement, it's completely in the interest of banks and against the interest of government. And a simple positive negative distinction wouldn't capture the context of that statement, because it always depends on the interpretation and the context and the addressed audience. So given these challenges, given these problems, what has the central bank communications literature done? There's two big strains, and I think this goes for a lot of data science. So many in the audience might be familiar with this. One strain is sentiment analysis, which is to say, most often we use a dictionary. The most popular is Logram MacDonald, to assign some strings of words a hawkish sentiment, that is to say, contractionary monetary policy, and some a dovish sentiment, that is to say, expansionary monetary policy. These dictionary methods are, of course, interpretable. I might understand what it means. So I think somebody has a microphone on. Yeah, so like I as a human might be able to understand what it means for a string to say pressure on wages that might be negative. But this does not capture the full extent of information content of central bank communications because it is context blind. For example, the string pressure on wages flags both downward and upward pressure on wages, which contains opposite sentiment. And it also doesn't contain information on what audience is addressed. So the problem persists of context and audience blindness. And also, especially for econometrics, this might be interesting, data coverage, right? N-grams have to be generated from a certain set if we're not using a dictionary method. And so within the set, there might only be so many occurrences of a certain string. And so producing them might sometimes be costly. And also, if you have a certain set of n-grams, it is difficult to get enough data points with those limited n-grams. The data set we used with all Fed speeches since 1952 only contains 11 occurrences of the 3-gram relatively high unemployment, which I dare to say is relatively little. And then, like, lastly, the problem with n-grams is that we have no idea how accurate they are. Anybody who's ever worked with n-grams might know that if they manually inspect what the n-gram has flagged, most often it doesn't make sense. Like, yes, they might mention pressure on wages, but it might be in a completely different context, hypothetical, etc. So that even if we get sentiment scores from these n-grams, they might not make sense. And we found no study so far that has actually verified the accuracy. So like nobody's gone manually through and counted how accurate they are. From our own experience, it's not too accurate, but there's no figures on how accurate these methods are for the central bank communications literature. Now there's another method that is topic modeling, and they use techniques such as TF-IDF or LDA, and they basically create a matrix representation of a document, and then for each word, input a value, and then based on the similarity in vector space or cosine similarity, they might group topics and documents together. One disadvantage of these abstract topic groupings, is that meaning cannot be directly inferred. Some papers go around this by taking an ideal type speech, such as Draghi's whatever it takes speech, to interpret the meaning of the topics that are of that topic and the documents that are grouped with it. But it is difficult to do econometrics with it, simply because we do not know what each grouping means. Now, also a problem is that the most popular techniques to generate these topic models are context blind. That is to say, if we have a topic around inflation, speeches that talk about rising or tapering inflation might be grouped together, even though they carry opposite sentiment. And lastly, because these groupings are generated within our sample, if the sample changes, the groupings might change. So it is difficult to create to compare across papers and across our data sets what these groupings mean. So it might make sense for a given data set. We might be able to infer what it means, but it is very difficult to compare across studies what a grouping actually means. So these two methods in central bank communications literature obviously have gaps, mostly context blindness, but also audience blindness, and for topic modeling, also interpretability. So we've seen this gap, and we thought maybe large language models can help with this. And just a heads up for deep learning models, most of you have probably used ChatGPT. Back in our day, which is to say a couple of months ago, the only open available model was Google's BERT, which is a bidirectional encoder representation from transformers. And basically what this intimidating name means is that it can interpret, first of all, context of a word embedding, and secondly, in both directions. So if we didn't have context, bank of the river and bank account, the word bank would mean the same in both, which obviously doesn't make sense. Bidirectional then adds that the system can distinguish the sentence, I access the bank, and I access the bank account, because it considers also the other half of the sentence and also goes in the other direction. So this allows us to capture context better than ever before, not unlike the human brain. So the strong suit of BERT and also of ChatGPT is to capture long-range dependencies in a way that more naive NLP techniques could not so far. And BERT, the nice thing about BERT is that it has been pre-trained generally on Wikipedia, and is open for researchers to pre-train, to further train for some more specific tasks. And this has been done for finance, for example. There's FinBERT, which actually a lot of people in central bank communications now use, because it's the most close substitute for large language models in the field so far. But there's no LLMs for central bank communications because there is no data set. There is no labeled data set that is available in which each sentence is assigned a sentiment manually so that the machine could learn. So given this, given the availability of BERT, and given that we've created a data set, we've created a pipeline for CentralBankRoBERTa. And to show you like the genealogy, to make it understandable, what we've done. BERT is by Google, it has been developed in, I think, 2018, has been pre-trained on Wikipedia and Google Books to generate some word embeddings. Then Meta, so formerly Facebook, has pre-trained, further trained BERT to remove the next sentence prediction feature, which Google created for Google search results. So you know what word comes next after you type in something. So Meta removed that to make Roberta now more efficient. And it has further added training so that it can better understand the context of words. And now we use Meta's Roberta model with our data to fine-tune it for one, sentiment classification, so that it is either positive or negative in the context of central bank speech, and for agent classification, so that our Roberta model can now distinguish financial sector, households, firms, central banks, and government. Now, what does positive and negative mean for central banks, right? We've seen hawkish, dovish before, but how can we make positive, negative interpretable? So what we did, we created 12,900 random sentences from our Fed data set and labeled them. And then we increased this pre-labeled data set through a method called pseudo-labeling to 29,000 labels, which is to say, on our pre-trained model, we use the most accurate predictions and then re-put them in the model. So this is our distribution for the data for each of the audiences for the Fed, ECB, and BAS. This is our distribution for positive and negative labels, which we've only understood in relation to the economic agent. And to give you an example, so for example, the sentence, on a very practical level, we reestablished our competitiveness in the financial services. That, of course, concerns the financial sector. And we might understand this to be positive because it is favorable for the financial sector. Another example might be continued success on the economic front depends largely on political reform, namely constitutional reform that will help restrain fiscal spending. Maybe that's positive for business because the government will stay out. But because it here talks about government, we've flagged this sentence as negative because with respect to the government, this constitutes a negative signal to the government. So I hope it is interpretable, our labeling methodology. Yes, and with this data set, our training, we found that our model outperforms most other NLP methods, be it LLMs or simpler machine learning models. And with our trained model, we've also found that we can generate more data points than most other models. So Moritz wrote a paper last year with the common method of n-grams and obtained 1,600 sentences on the same data set, with which we obtained 200,000. And that is with a high accuracy cutoff. So we only use predictions for which we were very certain that they were correct, which of course is a huge leap and can make econometrics a lot more robust. So this is the training curves for our models. For those who might be interested, we see that 93% of predictions are accurate for agents and 88% for sentiment, which is interesting to know because we don't know for n-grams. And I think that is a very good score that we might be proud of. So with this model that we've now trained, what can we do? One example might be for Fed data. So we can, for example, see what the Fed talks about. So for our data set between 1948 and 2022, we see that the Fed talks 34% of the time about the financial sector. It talks 20% of the time about itself. It talks 19% of the time about firms. So it's interesting and also not too surprising that the Fed talks most about the financial sector, then about the real economy, households and firms, and very little about the government. This is the distribution of data points throughout time. And we can see there's generally more negative sentiment than positive sentiment. And we can see, for example, which is interesting, that during the Greenspan era in the 90s, the Fed barely communicated. And we can also see that over time what the Fed feels for certain constituency changes. So for example, the Fed consistently exhibits a bias against the government, which is the pink line on the very bottom. But in recent years, since the great financial crisis, this has become more moderate. Same for banks. It is interesting to see how sentiment evolves and almost follows the business cycle. For example, firms, they've had their peak in the 90s and in the 2000s. And since the great financial crisis, firms haven't been spoken to or about too well. So it's very interesting to interpret what this means. And there's a lot of hypotheses we might test with this. So is the Fed speaking to certain audiences because they want the audience to feel a specific way? Or is it simply describing the audience? And that brings us to our last point for this presentation, the applications. Perhaps some in this audience are interested in such applications, and we would be happy to chat more about this. So some ideas for what you might do with our model. For one, this is the first model to distinguish audiences. So we might now study how certain audiences are receptive to central bank communications. If the central bank speaks more about households, do households feel more confident towards the Fed? We might also distinguish what other studies didn't do, how communication to certain actors influences those markets. So far, we've only studied the sentiment for the market, so generally, but we might expect that sentiment towards firms perhaps more influences corporate bonds, whereas sentiment towards households perhaps affects mortgage rates, etc. That would be really interesting to check. Another advantage that we have is the highly granular data. So what could be really interesting is to flag each sentence in a speech. So we know which sentence came before which one. And maybe if a speech is very positive at the beginning and very negative towards the end, do the financial markets react during the speech, right? And we might also now for the first time, because of the increased coverage, check how a certain central banker evolves through time, because we now have for each person enough data points. And also, how are certain communications reflected in the press? Because press articles always follow a statement. It is important that we have high density of data points so that we see what one statement did for the press specifically. And that would be really interesting to check as well. And lastly, interpretability, because topic models can't do this and n-grams don't have enough data points. We can now, for the first time, actually generate sentiment and be able to tell what it means. So, for example, it would be interesting to see on our large data set if central bankers differ the communication styles through different time periods, or if they, for example, have different syntax and grammar for negative sentences than for positive sentences. Maybe they want to cover the message up more. And lastly, from a data science perspective, perhaps it might be interesting, because we can see what labels our model produces, at what point in time we might need to update our model for it to stay accurate. And just one example for our model, this is Richard Fisher, who's by far the funniest Fed president of all. We've always laughed while labeling because he has such funny opinions. And so like this is a Texas regional Fed president, and we can see that throughout time, he's consistently positive for firms, and that after 2008, he became really critical of banks and perhaps less critical of government. So it's really interesting to see, which we can now do for the first time, what specific people do. And that's just one example, but if you play around with it, with our model, which you can find on GitHub and on Hugging Face, perhaps you find some applications for yourself. I also want to stress that we can now distinguish audiences, and perhaps that might be interesting for people who do not work on central banks, but for other economic related disciplines. So I would be really curious to hear what you could do with this model, and we would love if you send us an email to propose something. This is a recently finished work, and we're really curious to see where this might go. And with that, thank you so much for your attention. And I'm really happy to take any questions you might have. Thank you.
Thank you very much, Vincent and Moritz. I think we can start with the Q&A questions. And while I think, please, if you have any questions regarding the presentations and also the research that is being done by Moritz and Vincent, please put it in the chat, or if you want to, you can also raise your hand. And you can also talk about your questions. But while we're waiting for the questions to roll in, I also have some questions on my own as well. So I've also did some analysis of World Bank text corpus before, and I think one of the research questions that I was coming up with is whether or not these the communications of the World Bank's becoming more increasingly more complex and complicated over time. And I think back then I was using something very simple, like text readability with Flash, for example. And so I would actually be very interested to see whether or not you can actually see that happening using the same methods that you have illustrated here. But my questions here also related a little bit regarding your paper, because I was reading through the papers that you have published, and I was also curious about the pseudo labeling that you mentioned in the paper. Could you perhaps elaborate a little bit more about that, on the reason why you choose to do pseudo labelings to add in additional data in the classifier?
Yeah, thanks for the question. So maybe first for the pseudo labeling, the reason we did that was just to increase our database and not limit it to the Fed. So we just wanted to make the model as general as possible, and the data sets that are available for these type of communications are the biggest data sets are at the ECB, at the Bank of International Settlements, and at the Fed. So since we had the ECB and Fed and BIS data, and the BIS data actually includes, I think, I don't know, over 100 central banks. So we really have a good sort of overview there on all the central banks in the world. So for us, it was important to make the model more general. That's why we did that. And for your other comment on what was the other comment? I'm sorry. Your research on the World Bank. The complexity of the speeches. So so it's interesting to see for central banks that they actually over time became more clear according to these very simple metrics like the Flash Kincaid score, which basically just counts the number of syllables and number of words ratio in a given sentence. So over time, sentences of central banks have become shorter, and which could be interpreted as a signal of clarity. However, they also talk much more than before, so that makes it more, maybe less clear, right? Because the more you speak, the less clear the audience is on what you as the central bank are actually doing. So, and there have been studies that show that the more the central banks speak, the more confused market actors appear to become about what is going on. So there are all these, I guess, pros and cons that need to be weighted with this question.
Thank you very much, Moritz. We also have a question from Erika, who is currently doing analysis on the interaction between facial expressions and the text class using Finbert. And the question is, how do you compare your model with Finbert, for example?
Yes, thank you for the question. It's really interesting to see what people do research on. And as I mentioned, I feel like right now, most research working on central banks starts using Finbert simply because it's the most advanced model in that area, even though it's not specifically made for central banks. And so how do we compare Finbert and RoBERTa? We used both Finbert and RoBERTa. We imported it, and then we did some further training on them. And so the base training of Finbird with our data set generated less accurate results than the base training of RoBERTa with our data set. We didn't compare CentralBankRoBERTa positive negative sentiment with the positive negative sentiment of Finbird. Maybe that's still up for grabs, but I might expect that for central banks specifically, given that for our training data, RoBERTa was more accurate, maybe the sentiment might also be more accurate for CentralBankRoBERTa. But Arita, thank you for your question. I would also be happy if you send me an email to talk more about this, because I would really be happy to see this applied in such an interesting study.
So I think maybe the next paper would be a competition between the CentralBankRoBERTa and Finbird and also GPT, right? And then we'll see who wins in this fight. The next question comes from Mingma, who gives appreciations for the presentation and has specific questions about the identifications, annotations of agents, and how do you deal with the issues of sentences containing multi-agents and maybe sentences that maybe have multiple classes in there. How do you can you elaborate more on how do you solve this issue?
Thank you for the question. I've also peeked an eye on the next question from Jérôme, because they're both on the similar topic of multi-class labeling. So no, our model cannot immediately do multi-class labeling, simply because it was too tricky with the data we had. So what we did for our labeling methodology, the data is available online. So if you want to take a look and see what we did, to perhaps better understand the logic yourself, feel free to do so on the GitHub. But what we did for labeling, we simply labeled the audience that was most obviously implied by the sentence. But what happens is that, of course, if we talk about financial services, perhaps what's also implied is firms, perhaps to some extent, and simply because the similarity across sentences on average then works out that, of course, financial sector might be closer to firms than to, government. The accuracy for, or like the confidence of the labeling for financial sector and households might be closer than for government. So that connects to the question of Jérôme. No, if we produce a label, we cannot say it talks about the government and financial markets, but we can see in the labeling probabilities that government is perhaps more likely. So you could construct yourself sort of a multi-labeling tool where you perhaps take the two most accurate labeling confidence scores, and that way perhaps sort of create multiple labels for one sentence. And perhaps that way you could also create the sentiment scores for multiple groups. I hope that answers the question.
Thank you, Vincent, for taking care of both questions at the same time. The next question comes from Vanessa, who asks about how does the models here deal with numbers and figures in these reports? Is it able to perhaps integrate them into the analysis?
Yes, that is the other frontier of central bank communications right now. There is one guy in Oxford doing this called Maximilian Ahrens, whose paper is currently, I think, will be published soon. So he created a model that sort of makes sentiment dependent on whether the interest rate the central banker talks about is lower or higher than the current one. So he tries to address that problem by making sort of hawkish and dovish relative to what is currently the rate. Perhaps it could be combined with our model to add audience distinction. So far, our model cannot deal with numbers. We cannot deal with the relative interest rate difference. Perhaps in 1 or 2 years, it might be possible for you. But so far, we can only do what is it called, elevator economics, where we say this is good, this is bad, but only in terms of sentiment, not in terms of numbers. But I think maybe you can construct some proxy where you say positive sentiment correlates with more expansionary policy, and then that way sort of take numbers into your analysis. But I would be happy to talk more about that. So also feel free to send me an email.
Thank you, Vincent. Jerome has some follow-up questions. Are all sentences labeled? Because he guessed that a lot of them not have any evident labeling in the sentences themselves.
Yes, thank you. Yes and no. So our model always produces a label, but what happens is it produces for each of the categories a certain confidence score. And so usually you translate this confidence score into labels by taking the highest score. And this is why we mentioned earlier, with 80% confidence, it's 200,000 labels, because we can pick ourselves the cutoff point for our probabilities. So yes, all sentences are labeled, but you shouldn't make all sentences labeled, because then there's some inaccurate predictions in there. So play around with it yourself and see what cutoff you want to have. It will probably econometrically also be valid if you take all labels, but I don't know what might be the optimum for this.
Thank you, Vincent. And Jerome has also another follow-up questions. So when you train the model, you have to label them all. But when you choose the resulting data points, you can also keep only the ones above a certain threshold. Is that the case that is in your research?
Yes and no. So first of all, if you want to construct this yourself, and the way we did it, we only labeled those sentences for which we are confident. And that might be a good example for CentralBankRoBERTa to learn. So very neutral, very ambiguous sentences, we simply dropped out. So we only have sentences that are really interpretable. So no, you don't have to label them all for our training. And also you specifically don't have to label them all, because the model is pre-trained. So that step luckily is taken care of. And yes, for the resulting data points, we can only keep those for above a certain threshold. So yes, we also don't have to label them all when we produce the labels.
But just in addition, if you are, I suspect you are currently working on something where you are labeling, but correct me if I'm wrong. So for us, it was not necessarily, we didn't know beforehand how many sentences we had to label for the model to work, and we continuously tested the model like for every 500 additional sentences we labeled, and we saw that the model became better at predicting random sentences we threw at the model. So that's, I think, a sort of good experimental way of dealing with that labeling conundrum.
Also, in case you are labeling, please do feel free to take our data set, which is on the GitHub. I think it's the only one for central bank communications. And given we ourselves really hated labeling, and it took us 3 months, we would be really happy if we could prevent other people from doing the same.
Thank you, Moritz and Vincent. So maybe also just another questions. I think in the presentations, you mentioned that the models outperform quite a lot of other models that are existing in the market right now. Could you perhaps explain a little bit, maybe your intuitions on why that is the case? Like what is the maybe the intuitions behind this performance, and also perhaps do you want to venture a little bit into explainable AI and maybe apply some of the methods there to understand what's going on behind the scene?
Yeah, so if we look at the accuracy scores, there's of course some very naive machine learning methods. So TF-IDF is topic modeling, and the big surprise for us was actually that SVM, so support vector machines, which I think was developed in the 80s, was actually really good. So it was 83%. But then between the large language models, why is this ranking the way it is? Well, BERT, I think, is less good than RoBERTa for the obvious reason that RoBERTa has more training data. So it's 16 compared to 160 gigabytes. So it's just better at nuance. FinBERT was the same as BERT because it is BERT. So I think they simply added some training data from accounting. So I think it was about financial statements from private sector firms and if it's good or bad. And so if they say, oh yeah, we have to pay less in taxes, that does not add something to CentralBankRoBERTa. So FinBERT is the same score as BERT because it is BERT plus irrelevant training data for our task. And XLNet, it's pretty interesting. That's basically the public version of ChatGPT back when we did it, and ChatGPT wasn't public. It's interesting that it's almost as good as RoBERTa, which perhaps is indicative of the performance of ChatGPT. I'm surprised that it's not as good as RoBERTa, but I think at the time they didn't have as much training data. So I think the ranking of LLMs is almost 100% a function of training data going in, and RoBERTa simply had the most.
Thank you. Mingma has follow-up questions. He thinks that your approach set the center scope for label class government, households, or financial sectors. And he was wondering whether or not you could give more rooms for the models to extract more broad agents and then further set more micro-level class for these identified entities. And do you think that this approach could perhaps enlarge the application scope of this current model that you have?
That's really interesting. So yes, I think you might definitely expand the model. It would be difficult to expand the model as we have it, to include more categories, simply because you would then have to label a lot and retrain the whole model. But given that our model isn't set in stone, you can definitely play around with it and see how you might combine it. For example, for our next paper, we're currently combining topic modeling and CentralBankRoBERTa to isolate topics and then give them an audience and sentiment label. And what Ming might do is combine the labels we produced with named entity recognition and then sort of create for that named entity specific sentiment. But then you would have to combine our model with another model. So yeah, I think if you wanted to add something to the model, I would rather do it with an extra step rather than retraining the model. But feel free to shoot me an email. I think it's really interesting to think about these problems and how to combine approaches, and I would be happy to talk about it.
Thank you, Vincent. And maybe while we're waiting perhaps for the final questions, could you perhaps elaborate a little bit more on what is the next step that you want to do with this model, and where do you see the advancement going in this field of researching central bank communications using NLP methods?
Yeah, I also wanted to add this to what you've been saying earlier, because you analyze World Bank data, right? And I think what's pretty cool is that CentralBankRoBERTa actually is very applicable to other things. So FinBERT was for accounting and for firms. So for the private sector, that might be their domain. But CentralBankRoBERTa is really good at recognizing government-related policy, central bank policy, and sort of general macroeconomics. And I think it might be one of the only LLMs for that field, for macroeconomics at large. And so what we're doing right now is we take firm transcripts from about 10,000 firms for every year. So I think, what is it? It's about 250 gigabytes of data, and label every sentence. And then we create a time series about how the firms, the representatives, because we have sort of transcripts from their calls, how they talk amongst themselves, among the board. And we label the sentiment and who they talk about to create a time series about what firms feel about the economy. And it's really interesting because there's some literature about this that's currently really in development about sort of animal spirits, as in canes, how sentiment travels through the economy. And it's really interesting with this big data set to see how sentiment spreads from firms to firms. And currently the literature has sort of found out that sentiment explains a lot of the business cycle. And what we are currently aiming to add to this literature is to try to isolate with topic modeling the sentiment that stems from central banks. So we might remember the transitory inflation that Paul has mentioned. If we now group the topics around transitory inflation, we might see how firms specifically feel about this topic. And then it's interesting to see how what the central bank says influences the sentiment around that topic in the economy. And it would be really interesting to classify sort of how that contributes to the steering power of central banks, because they can control what the economy thinks and how that interacts with the business cycle. So yeah, that's where we're going. The only constraint that we have, and that might be interesting for the people in the audience, is GPU capacity. So for most data sets, central bank communications, I think it's fine to do it in Google Colab. You can even do it with a free subscription. But right now, 250 gigabytes of data takes a long time. At the business school, we only have one GPU server. And right now, it takes about 2 months to finish labeling. So yeah, that's one thing to maybe aware of, or to have a good institution with a nice server.
Thank you very much, Vincent. I find it very, very interesting when you talk about the text regarding animals traveling, and it's becoming basically a major component of these communications. It reminds me of the stories about the people when they were doing archaeology digs and they found out all these Sumerian tablets, and they were wondering what all these texts were about, and they spent so many years trying to decipher that, and then they found out in the end that all the text was just about herding animals and exchanging of animals for money in ancient times, which is quite interesting that we have the same problem as people from thousands of years before. They also have the same issues, and it's all in languages as well, right? So that's very interesting. And if there's no further questions, please feel free to reach out to Vincent and Moritz to talk about their models. I think we have quite a few people in the audience who are doing very similar things, so please feel free to talk and communicate with them in case you want to collaborate for future projects in the future. And thank you very much, Vincent and Moritz, for introducing about your models to the audience today. Hopefully you will continue to develop this and create something even more amazing and great so that we can actually try it out for our future data sets. Thank you very much. And have a nice day. Hope everything's going well, whether or not you're in America or in Germany. Thank you. Take care. Bye-bye.
Thank you very much. And my email is in the chat if anybody wants to text me. Thank you.
Same for me. Thank you.
Take care. Have a nice day. Bye-bye.